So we have parallel and serial devices. So parallel means a bunch of signals going at the same time. So that's parallel. And if we have them serially, it's just a one line. So we can only transmit a 1 or a 0 every second. So, or every, fraction of a second, however fast our chips are communicating. It's such and such a bit per second. That's how fast the chips can communicate. I can put a signal high for a fraction of a second, and then the other chip can understand that they're changing at this rate, so many megahertz or hertz per second. So this is an example of parallel. So I can transmit multiple data in parallel, or I can transmit one character at a time over serial. So there's a communication standard for all of this, how things work. And the American Standard Code for Information Interchange, or ASCII. So it's a standard for representing text, characters, and binary code. The basic standard equals 128 codes, so the basic standard, and then we have an extended ASCII character set, which is 256 codes, where you get all kinds of little codes and characters, right? So we have an 8-bit bus, and then we have a 16-bit bus. It's just 8 lines versus 16 lines. And that's what a bus is. It's just a set of transmission lines. And then we have a bus system, where the first house can talk across those. Let's say, for example, this is illustrating a serial connection where there's only one line. But let's say, for example, we had an 8-bit bus across the lines there. There's 8 lines running across. Each house can address those 8 lines independently, but not at the same time. So they actually need a control system to say who's talking and when, right? So we'll get into that in a little bit later. So chapter summary, computers communicate using binary notation or base 2 math. So that's another thing where we're talking about here where the bits are 2 to some power. That's a base 2 system, right? So that's a base 2 number system. And that's what we're using here. That's what they mean by base 2. So then the actual positions represent the power, right, of that number. So ASCII is the standard communications code for most modern computers. There are other sets. There's EBCDIC, there's all different kinds. In Europe, there's, different character sets for Chinese and all different kinds of languages. Everything's represented, but it'll boil down into one universal standard. So there's a bunch of translation that needs to happen for the screen to represent something, but inside the guts, it's going to boil down to just a handful of sets that we're going to use. So ASCII includes a basic standard and an extended character set. So because we needed more representation, so that's where the extended character set came from. And then serial devices transmit 1 bit at a time. Parallel devices can transmit multiple bits at once. You can transmit 8 on an 8-bit bus. You can transmit 16 on a 16-bit bus. You can transmit 32 on a 32-bit bus and 64 on a 64-bit bus from one point to another. We also use the same methodology to address RAM and stuff like that, but we need an extra line to say which chip we're addressing at a time, right? Which memory location we're trying to address at a time. So part of that bus structure might be used to address the memory, and part of it might be to transmit data to the memory, right? So we'll talk about more of that, about that kind of stuff later.